Welcome to VibeReversing binaries with R2AI, Decai, and R2MCP. I'm Sergi Alvarez, also known as Pancake, the author of Radare, and I work as a mobile security research engineer at NowSecure. I'm a free software enthusiast and developer. In this presentation, I will be showing you common use cases about using AI for reverse engineering. Basically, nowadays, all the companies are using and integrating AI technologies for every single tool that they do. Basically, because it's expanding the capabilities across all these industries, also integrating new tools in a very fast way and lowering the entry barrier for new users, because users don't really need to understand how the tool works, because AI will give a human language interface to use them. And the same way, it's simplifying complex workflows and enhancing the creativity and productivity for them. But these benefits don't come for free. There is some concerns that are raising, and training and running these models requires an insane amount of energy. So it's not just the natural resources that we are consuming, but also the privacy concerns, because submitting all the data that we have in local and with all our use cases, the source code, the common problems that we face every day, it's increasing the privacy problems that we already were facing before that in an insane exponentially. So all the common tools are designed to not run in local models. They are designed to run in cloud services. And the problem is that as this is limiting the use cases for them, because at the end you aren't that tied to a payment software that you don't control, and they can change that at any time. So it's not just the language models are not predictable because they don't give you the same answer twice, but also that they will be under control of someone else that it's running and paying for that service. So with all these concerns in mind, we'll say that in R2Line we care about the privacy and user control of all that. So that's why from the very beginning in 2022, when I started working on implementing and integrating AI with the R2, I was mainly interested in understanding how this technology works internally. And not just that, but also trying to implement from the low-level side running local models and trying to use them and reduce the amount of consumption and energy that we need for them. So understanding from the very beginning was key for me to understand the technology and also to find out the best use cases and why the hallucinations happen and how to fix them. So initially, in 2022, I was working with third-party services because there was actually no public models. But Meta released Llama. Llama was the first open source language model that was able to use for the masses. And I was playing with the Python MPI. So it was very easy for me to integrate R2Pipe with a Python plugin that was basically integrating and using this Llama CPP. The main problem is that this model was running inside the same process. This means that if the language model was taking a lot of memory or it was crashing at any time, basically we were losing the whole session of Radare. So the whole process was crashing and you lost all the progress in one analysis. So there was some design issues in that process, and running third-party software like Llama CPP server or stuff like that was not viable. So since last year, there was a lot of improvements in being able to run local models. So for example, we jumped from 4 kilobytes context size to 200 kilobytes of context. This means that now you can submit much more text and process that in local. This is mainly the reason why new attention algorithms has been developed and integrated into different inference engines that give us the ability to work with larger data. Also, tool calling capabilities has been restricted from the very beginning to be only used on models trained for that purpose. But the thing is that I will explain that later, but basically tool calling doesn't really require models that are trained for tool calling. You can actually emulate the same thing using smaller models like 500 megabyte ones, and be able to reason the question, understand which tools are needed, and choose which one we need to call, without depending on JSON or grammars or anything like that. Also, the initial implementation was in Python, which was introducing a lot of problems because usually when you run a plugin inside Radare that is tied to a Python version, you need to run and install all the dependencies of this Python environment for the same version. So at the end, you end up having like different virtual environments, different Python versions, and the tooling was not working well because some of these versions require hardware plugins, like integrating with the NVIDIA card or the Apple cards and so on. So it was kind of problematic. Also, another limitation that we had is that the way that you submit the query to the language model, it requires to be templated in a way that the model contains all the information using the tokens, the special tokens that are used for in the datasets for training. So this means that each model have a different way to submit the same question. And initially there was no standard for that. So I was basically doing prompt engineering with the special tokens to construct these queries. And this was allowing me to have the ability to jailbreak and bypass some of the limitations that some models had. So for example, some models then allow you to write an exploit or explain a vulnerability because these are censored in question. So this is topics that end up into an answer that is blocking the model to continue the conversation. So with all that, I rewrote R2AI in C. So I was initial project developed by Dinakov, and I'm currently maintaining this rewrite. So fixing all that stuff was implying rewriting it in C, using third-party inference engine services, like for example Olama or LM Studio that can be running in local. And this kind of services just run in local, but they are running in a separate process. So we basically fix the problem of loading all the data inside the same process. Some of the new features that come with R2AI is that I try to decouple all the logic that was embedded inside the plugin. So initially, when you want to decompile, you're basically taking the decompile output from the R2, like for example, PDC command or PDG for R2 Ghidra, and then using a prompt to post-process this text and generate the final output with some tweaks, like for example, use better variable names, or remove boilerplate code, or write or give me the output in one specific language like Swift, etc. So as long as this pattern was pretty common and pretty easy to follow, I decided to write prompts. Actually, Visual Studio Code have like a prompt template syntax that defines the how the coding agents need to perform some specific actions, like defining which tools need to be used, which prompts, which fields needs to be which gaps needs to be filled inside the prompt, and then finally give you the output of that. So you can also use a specific model and provider for one specific prompt. So at the end, you have utilities that can be extended with your own text. So for example, you have, you can see here, we have like the different templates like explain, devices, libs, var names, and you have the description of these prompts. But then if you use like explain, you can also explain in Catalan or in Japanese or in another language. So if you type in the language name after the question, you will get the prompt tweaked to contain the text provided by the user. So at the end, the language model will be also following that instruction. These kind of prompts are very easy to write, very easy to maintain, so I invite you all to contribute and submit your user prompts. Can be very useful for find vulnerabilities, to write exploits, to analyze some specific functions, try to understand or extract some Java rules out of a function, and things like that are very simplifying a lot the development process of R2AI, because I can basically decouple the logic of use cases to the logic of the whole plugin from inside. About tool calling. Tool calling models used to require quite a lot of memory, like from 10 to 20 gigabytes of RAM at least. And the thing is that it's not just that the model takes that memory, is that every single query that you submit takes that memory. So you cannot do tool calling in parallel with many tools. So another limitation is that many of these models don't give you the ability for doing other things. So maybe you just want to do tool calling with one model and then the reasoning with another one, and then you want to do the actioning with a different model. So R2AI allows you to set up all that logic. And one of the options that I implemented was the auto row mode. The auto row mode changes the code that it's implementing the tool calling decision algorithms, that instead of using grammars or JSON, it's just using emulation for that. And to emulate that using language models is just sending the text that asks the model to output one specific text and process the tool listing with the original prompt in mind. So when the user provides them prompt, the language model is able to reason which tools are needed to solve the problem, create a plan, and follow the instructions to find the solution. So at the end, if you want to solve a crack-me, just need to use R2AI, specify which model you like, and then you use R2AI-A to enter the auto mode to solve the problem. So then it will enter in a loop, asking you to execute the commands or give you some comments as hints for the language model to continue developing the plan. And then when the model takes all the data that is relevant for the problem, it will be giving you the answer. So R2AI supports row mode for tool calling. This was inspired by Mai. Mai is an AI framework that I'm developing in Go, and it's like a great playground to experiment with all that stuff. I will recommend you to use it. It's not tied to Radare, but you can use it for any operating system and use case, and it's also supporting a lot of providers. And it's my playground for finally deciding which kind of features I would like to implement in R2AI and Decai and so on. So let's jump into the demo. So first of all, we'll check with R2AI using R2PM. So as you saw, there is the R2AI Docker and the R2AI package. The R2AI package, it basically ships a couple of things: the native AI plugin and also a command line tool that it's called R2AI. As you know, all the plugins and all the programs installed with R2PM end up installed in your home. So basically, if you want to run a program that is installed by R2AI, or you change the path to point to your R2PM bin path, because you can basically check the bin path here, you can basically call that using R2PM-R and then R2AI. So this is a command line interface that allows you to open a binary, execute the prompt, select the provider, the model, and run the query or one specific text for that. Also, you can edit the R2AI RC file. All the keys are stored in a separate file, so you don't need to keep that in the environment or not even inside the RC files. This is mainly for safety reasons, because this way you can share your configuration files without or export the whole environment without being afraid of leaking data. Okay, so next thing that we will do, so we know how to install it because we need to run that one-liner. So what I will do now is basically launch R2AI from the command line. We'll go into the VibeReversing directory. I will be sharing that in the Git repository, and we have out, which is basically a compilation of this program. So I can use R2AI-H. As you can see, there is more options now. And what I will do is, using -P and -M, we can see which model are selected and which provider is used. As you can see, this is Olama. This is running in local. Actually, I'm not using this local machine for doing that because I'm recording the videos. I will be taking part of my GPU time just for the video thing. So I decided to use a separate base URL. So I'm just pointing that to another machine here in my local home. So what I will check is with -q, we get the list of all the tools. So I want to analyze the main function, and let's say I want to check for vulnerabilities in this function. So the model is running, and we get the answer. This model is actually 2 GB in size. And you can see that this function is basically detecting that there is a stack check file, and the code appears to be handling using a string copy. It basically complains that this string copy is not safe. So basically we'll be overwriting the call, and it's explaining that, okay, I need to use be overwriting the stack cookie and providing excessive input with the string copy. So I can ask the model to write the exploit with that, or I can maybe change the model to get like a better response. So let's try with Gma 12b and make the same prompt. You can see this is a 12 billion model, which takes more memory and also takes more time. But hopefully we'll get like more verbose explanation about the problem. Also, as you can see, by default, if you check the code in R2AI, we can check the prompts, and we can see that the bools is using PDC. So it's basically using the internal decompiler of Radare. So we can change that to use PDG and provide the output from Ghidra, the compiler, to the prompt. So we get another better explanation. So let's try to change that. So let's say I want to use -e cmd.pdg to use the pdg command when the pdc command is executed, and then I will say that I will just give me the exploit. It's processing. So meanwhile, we can check other prompts, like for example, this one that it's executing different commands and joining them together, so we can group all the imports of all the libraries in this graphics purpose and usage. So this is very helpful to analyzing large binaries, because this is basically giving me the quite fast overview on the binary and understand all the functions that this program is using, and for which functions are related to one specific library. So we now have the program that's basically specifying how to write an exploit with a simple Stack Overflow use case. You can see the output is not direct. We can be playing with the prompt and so on. So okay, let's continue with that. So we then have Decai. Decai was a rewrite of R2AI in R2JS. So basically that's the JavaScript runtime that is shipped by default in Radare. So you can write TypeScript and JavaScript inside Radare. And the main focus of that was the compilation. So the reason for that is because JavaScript is a much easier language to iterate, so you can be modifying the code very easily without having to recompile. You can process JSON output very easily, and at the end it was an easy way to experiment. Like for example, create like different output from different compilers. Let's combine PDD with PDC and then the Ghidra decompiler, and combine all the 3 decompilations into a single function that makes more sense. And also, not just that, but also we can create pipelines, like Every time that the model creates one generation of the output, we can pass this model to one specific prompt and model to generate another optimization for that. So we can use one specific model that we know that is good for cleaning code, another one which is good about giving good names for the functions and stuff like that. So let's say how that works. We can open the password check binary, which is a Swift application. We can see that if we check with the Git of the compilation, it's kind of verbose, and we don't really see, apart from the comments, how that code works. We can use PDC, which is even more verbose, or PDD. But at the end, the logic is quite confusing here. So I will be using Decai to compile that function. And one of the cool things of Decai, or actually using AI for the compilation, is that you can also specify not just the actions that you want to do, but also the output language. So right now I'm using Swift for the compilation, but I can also say that I want Bash. And you will get the compilation of the function as a Bash script. Take some more time. But you get like a working Bash script that basically verifies that the password is 123. Decai also supports the auto mode, and this was natively implemented without supporting and requiring tool models. So you can execute Decai -a and then the query, and will be acting in loop until it solves the problem. So let's talk about the model context protocol. The JSON RPC standard was for the model for communicating agents and tools was defined by Anthropic, and this was pretty straightforward and useful for many AI software, because it was basically extending the capabilities of the agents in order to be able to execute native code or interact with other projects or tools or APIs over the network on libraries. As you can see in this image, the agent is using HTTP and JSON to communicate with the language model, but then it's communicating with different services, which can be local programs that run in your machine or HTTP endpoints that answer using JSON. The cool thing of that is that the agent can pull and get the list of all the tools that the MCPs are providing, and then choose which tools need to be executed in order to respond to the user. Most of the agents end up doing this internally, so users don't really know what happens there. And this is kind of a problem, because if you are using third-party MCPs that you don't control, they can be pulling data or even doing prompt injection to execute other tools behind the scenes. So it's important to have full control on that. So MCPs usually are used for tools, but they also provide resources and prompts. Prompts can be very useful for extending the capabilities of one model, because you can explain how to use some specific tools for solving specific problems. And resources used to be kind of like static files that provide a catch or summaries and context information for one specific use case. So resources can be used, for example, to storing comments or hints that the language model have been creating over time, and for example, for solving one specific reverse engineering one specific binary. And prompts can be useful for explaining how to find a vulnerability in one specific code base or programming language. So R2MCP was basically designed with all in mind. Setting up one MCP is very easy. Just need to edit the JSON file. So in my case, I will be showing you how to use OpenCode to modify this, but this JSON works in the same way for Cloud Code or Visual Studio Code and even the framework that I was mentioning before that I'm developing. So actually you just need to specify an object in JSON with the MCP servers, and then the name of the server, specifying that this is a local program, the command that needs to be executed for that, and then if it's enabled or not. This is very useful because then you can enable or disable them at any time. And I will explain that now, but I will be showing that later. So basically the -m flag or R2MCP reduces the amount of tools that are provided to the agent. This means that instead of having like 30 different tools, it will be only providing 15. And the reason for that is because having less tools is sometimes better, because the model cannot be confused running tools that probably don't provide the answer because the description was not correct or probably not as clear as the model was expecting. And also it can be confusing and taking more time to resolve the problem. And at the end, having more tools implies consuming more tokens. So the more tools you have, the more tokens you will consume, and also it will be taking more time to process. And also you have the -u. The -u flag allows you to specify the URL of the R2 endpoint that needs to be connected. So instead of opening a file using the R2 APIs or spawning a new process, we will be basically connecting to your running session. So you can have Radar in one terminal and then communicate with that binary using R2 MCP from another terminal, and then reuse the analysis that you have there to extend that with AI. So let's see how that works. The R2MCP is a program that gets executed in your machine and allows the agents to communicate with that. So there is like mini mode for reducing the amount of tools that I was explaining. There is also sandbox mode, read-only mode, and the supervisor console. The supervisor console is kind of like when you try to execute a tool, the coding agents used to ask for permission unless the YOLO mode is enabled. So when you need to accept or reject one of the actions that the agent is going to do, at the end you have only two options. You can accept or deny. The problem of that is that this is very limiting. This is just not allowing full control on the users, because you don't have control on which data is getting processed. You don't have control on which tools are gonna be executed after that. So what the supervisor console gives you is the ability to not just reject and accept, but also to modify the parameters that are sent, to modify the tools, to execute a different R2 command, to give a response or a hint to the model to understand how to solve the problem better. And then all this stuff is running in a separate process. So basically you have the agent that can be anything that you like, the R2 MCP, which runs inside the agent or remotely in another machine, and then you have the supervisor console that is basically the MCP who is asking you for accepting all this stuff. So basically, apart from that, all the tools that the R2 MCP supports allows you to execute not just R2 commands, but also common actions. You can also execute JavaScript snippets, so the models can write R2.js scripts, execute them, and get the output out of that. It supports logging, which is very helpful for finding out what's going on. It can be also used for scripting, and there is a domain-specific language that is used for testing, but can be also used from inside Radare. This means that you can use R2 MCP also as an R2 plugin and execute functions like list functions or analyze program using natural language instead of having to learn and remember all the R2 commands. But R2 MCP is not the only MCP that we have. There is also R2Copilot. R2Copilot, it's another MCP written by Daradelium, which is another contributor of R2 ecosystem. And this MCP is written in Python, and it's based on top of R2Pipe. This MCP have a different focus. It's not the same stuff that I was explaining in R2 MCP, but this one focuses on solving CTF challenges. This basically means that this agent allows you to be used from different agents. So basically the MCP server handles different sessions. It's able to load different binaries at the same time, but also provides a bunch of interesting features like ROP search for gadgets. You can also do binary patching, debugging, and processing so many different things that R2 MCP is not providing by default, because it's only focused on reverse engineering basic use cases. As you can see, if you run may WMCP with -t flag, it will be you can pass the MCP binary as an argument, and you will get the list of tools. And so you can basically grep for tool name, and you can see that R2Copilot is providing 43 tools. I'm encouraging all of you to test this MCP. I think it's very useful and handy, and give us some feedback. Also, let's make a quick demo with R2MCP. So let's start by configuring the code editor. So in my case, I will be explaining how to do that with OpenCode. So in OpenCode, as I said, we can have a bunch of different MCPs ready for use. And as you can see, I'm using the mini mode here. And it's enabling all of this one and disabling the other one. So let's say that I want to start OpenCode, and I will tell the model that, well, first of all, I will jump into a directory I don't care, and I will ask the model to use, tell me which Arch OS is supposed to be executed, the /bin/less using R2MCP. So as you can see, it's using R2MCP tools to open the binary, get the results, and give me the output. So let's choose a different model, like for example, GPTOS, or you can use, for example, GLM or Kimi. So you can basically choose whatever model you like that comes with your code editor. Okay, so as you can see, this was basically quite fast, and the tools has been selected easily. So let's start this from scratch, and let's say list the libraries that /bin/ls program is using R2MCP, and explain the use case for each of them. So I was using the voice, now I'm using GPTOS, and we get this nice output in Markdown with colorful stuff. It's telling me the relationship between each of the imports, the library it is related to, and explaining me how are they used for. So let's see how that supervisor mode works and how the WMCP thing works. So if we get R2 may WMCP, you will see that there is a bunch of flags. So we can basically get the argument. So we can use, for example, may MCP weather, for example. So we'll start the weather MCP that give me the ability to get information from the weather. And there is like 3 tools loaded with that. So we can have another terminal that will be pinging this model in order to resolve the problem. So I can also use may tool, so I can list the tools that are available, and I can just call get weather, which requires an argument. As you can see, there is a list of actions that they can take here. I can approve the execution, reject, permit, or approve all the tools, or modify the name and parameters that are going to be used. So let's approve that. Get the response, and we get the output from that. So this is how the MCP supervisor console works. You have the tool that is executed from inside the agent and gets passed to the supervisor, and you get the response in exchange. The R2AI model is a foundation dataset that was started to be built from scratch and reviewed by humans. This means that we are basically building a question-answer format that is used by AI to review all the actions that we want and which comments needs to be executed for that. The thing is that the plan is to basically have like automated loops that use AI to understand what actions needs to be done, how to verify that this action is done correctly, execute the commands, verify that this is correct or not, find different alternatives to solve the same problem, and iterate until we get like a full data set of information, not just about question and answer, but also reasoning plans to solve reverse engineering problems. And at the end, this is not just helpful for solving problems, but also for improving R2, giving better documentation, improving the help messages, and finding better use cases and understanding better how the command should be working. So I will encourage you to check this project if you want to contribute to that. And because it's not just a simple project for AI datasets. The idea is that we can use this dataset for fine-tuning models and use that in iterate to improve the whole support for Radare. Also, I would like to make an honorable mention to which is my artificial intelligence. This is the repository if you want to give it a try. You can use it from the command line. There is also a UI. It's providing you with a powerful REPL shell that you can modify and use pipes, redirects, backticks, and replacement side like in a POSIX shell. And also it integrates with different providers, different models. It works well with tools, able to jailbreak models. It's also integrated with Beam, so you can basically use Beam to call the language models and modify some prompts or some text. And at the end, it's a very easy way to get used to understand how that stuff works without depending on any private solution. If you have any question, please reach me out in the Fediverse or in any of the channels from the conference or the project, and I will be listening to you and try to help you as much as possible. So thanks for watching and see you soon.